Here we are at example 6 from our 8.3, number 270 notes. We're asked to graph the following rational function. What we normally start out with is going ahead and identifying what is our horizontal asymptote. And in just looking at our degrees here, we see that the degree on top is larger than the degree on the bottom. And as a result of that, we will have no horizontal asymptote. So none. Next, typically what we want to go ahead and do is factor the top and factor the bottom. And when we do that, we end up with x squared minus 4 times x squared minus 1. On the bottom, when we factor this out, looks like it comes out to be x minus 2 times x plus 1. It looks like we can actually break these down further. Right now we see the difference of two squares here as well as here, and that x squared minus 1 and x squared minus 4. And as a result, we can break that down to x plus 2 times x minus 2, and then x plus 1 times x minus 1. On the bottom, we still have our x minus 2 times x plus 1. Next, we're going to go ahead and cancel our items. So it looks like these x minus 2's end up dropping out, and the x plus 1's also drop out. So our final simplified version for this rational function comes out to be f of x is equal to x plus 1, I'm sorry, x plus 2, I should say, times x minus 1. In the event that we saw those cancellations happen, notice the entire bottom was canceled off, and as a result, when we set it not equal to 0 on the bottom, we end up with no VAs left over. So the vertical asymptotes, there are none left over, because again, everything canceled out here. For the holes, on the other hand, both of them are set equal to 0, or not equal to 0, depending on how you want to look at it. And we then just have to solve for x to see where are those holes happening at. Adding 2 for this first one, we end up with x cannot equal 2. And then if we subtract 1 from this one, we see that x cannot be negative 1. Now, we have the x values, but we need to go ahead and find out what are the corresponding y values. And we find those by going ahead and throwing them into our simplified version of the function. So again, this is our simplified version of our original function. Next, so as a result, what we're going to do is go ahead and throw in 2 into the simplified version, see what we get. So when we do that, we end up with f of 2, pretty much just taking this x value of 2, throwing it into our function, that's what this says right here, is equal to 2 plus 2 times 2 minus 1. So it looks like he comes out to be 4 times 1. Minus 1 is just 1. As a result, looks like he comes out to be 4. So the first hole looks like he comes out to be 2, 4. For our second hole, we do the exact same thing, only we're throwing negative 1 into the function. So we have f of negative 1 is equal to negative 1 plus 2 times negative 1 minus 1. Negative 1 plus 2 comes out to be positive 1. Negative 1 minus negative 1 minus 1 comes out to be negative 2. So it looks like this y value comes out to be negative 2. And as a result, that hole then is negative 1, comma, negative 2. So we've done the horizontal asymptote, vertical asymptote, holes. Next we would look at slant asymptotes. And just going ahead and looking at our original function, we notice that the slant asymptote will not actually exist here because our degree on top is more than 1 degree on the bottom. Like, for example, if this was x cubed, then we could go ahead and do long division to find out what it is. But unfortunately, it's more than 1 degree in the bottom. So for our slant asymptote, we just won't have one. Next, typically we find the x-intercepts. And we're going to go ahead and use our simplified version for that. If we imagine that we're trying to cross this x-axis, finding these x-intercepts, the y values are always 0 there. It doesn't matter where it's crossing here, our y values will always be 0. And that's exactly why we could take our simplified version, f of x, and set that f of x equal to 0. On the left side, our f of x, or y value, every single time is 0, is equal to our simplified version of this function. So x plus 2 times that x minus 1. And from here we know that we can go ahead and use that zero product property, breaking each item up and setting each one equal to 0. So x plus 2 is equal to 0, and x minus 1 is also equal to 0. Solving for each item, we end up with x is equal to negative 2, and x is equal to 1. So for our x-intercepts, it looks like they come out to be negative 2, comma 0, and 1, comma 0. Finally, what we typically check for is if there is an asymptotic crossing, but we notice that we have no asymptote to compare it with, that horizontal asymptote. So as a result, we are actually now good to go ahead and graph these items. We'll first start off with our holes, since we don't have any horizontal or vertical asymptotes. And we said that our holes were, again, at, no, it's 2, yep, 4, and negative 1, negative 2. We have 2, 4, which is right here, and negative 2 should be negative 1. Oh, negative 1, negative 2. Negative 1, negative 2. We also have our x-intercepts at negative 2, 0, and 1, 0. So negative 2, 0, and 1, 0. And pretty much, just with this little limited information, looking at our simplified version of the function, this is really the only way I could possibly see it. If you were to FOIL this out and distribute these items, you would end up with an x squared term. X times x is x squared. Looks like you'd have plus x minus 2, and ultimately this should create a parabola. So this should be like a U shape, and because that a term is positive, it should be facing upwards. So as a result, you could plot some points, but kind of in short, you just should see a U going upwards. I think what I'll do is go ahead and graph the y-intercept here. Looks like if you were to throw in 0 in for x to see where is it crossing this y-axis, looks like he would come out to be negative 2. So that would be right here. And because parabolas always do mirror based on that vertex, it should, I don't know the exact y coordinate. I do know that the x value would be negative 1/2. But let's say, for example, it would be right here. Well, then a rough sketch of what this graph would look like would be something like this. Just really quickly, I'd love to check through Desmos to see our final image. And here we could see our function entered in. Here is, in fact, that parabola, negative 1/2, negative 2.25. That's that vertex that we were seeing. And we should also have some holes happening at that negative 1y value. Let's get rid of him. And it looks like, yep, there he is. You can even, in fact, see through the Desmos where it creates kind of that hole. Also around 2, 4, we said. So, yep, there is our other hole. Again, though, that is our example 6 from our 8.3 number 2 set of notes.